Good. Oh, yeah, we good. Okay, okay, cool. So this time we're going to be talking about statements and control flow. So we've actually already looked at some statements in our last session. Again, I'm going to take my outset in the documentation, which I again urge you to go read and get used to reading documentation. Like let's imagine that we didn't know what statements were. What happens if I just Google C# statements? Right, we actually get the MSDN docs as the two first links. Um, so if we scroll down, we can see that there's a list of the different types of statements that we have. And when my body is done making weird noises, we can look at the first one, which is declaration statements. So I'm going to hop into our project from last time. Learning, there we go. And then it was teaching, C#, and I can just double click the solution. Take a sip of coffee. There we go. I should have probably opened this before I started streaming. There we go. So let's look at the first one. So the first one is a declaration statement. And for that, we have variables and constants. So we've already looked at declaring a variable. Remember, that was a type. So we can do int and then an identifier or name or symbol. It can be any of those things that it's usually called, uh, such as myInt. And now we have declared a variable. Notice again that we have a semicolon at the end of every statement. And if we read the docs, it will also tell us under the statements that a variable declaration can optionally assign a value to the variable. So that's what we've already tried before, where we immediately put a value into it rather than doing it on the next line, such as that. Right. So we're already plenty familiar with that. Now, let's just go ahead and cross that off. So what is a constant declaration? Well, variables, as is sort of in the name, can have variable values, whereas a constant has a constant value, so it does not change. Now, how do we do a constant? So before the type, we just write const. So now this is constant. And another thing you'll notice, if we do not assign to it immediately, there's an error because we will never be able to assign to it after this statement. So we need to assign it a value in that same statement. Otherwise, it's going to have no value. So let's do 5. And what happens if I say myInt++? Well, I get an error because the operand of an increment or decrement operator must be a variable. And this is not, this is a constant. So use constants when you don't want the value to change, when it is quite literally constant. Whoops, wrong button. Please don't. There we go. Now we have expression statements. So expression statements are just anything that evaluates to a value. That's an expression statement. And an expression statement must always be put into a variable. So I can't just write 5 plus 5, right? That's an error. 5 plus 5 has to go somewhere. So we could, for instance, put it in a new int. So this is an example of an expression statement. Then we have selection statements. And this is where control flow, if I can pronounce things, starts getting important. So what do I mean when I mean control flow? Well, remember how we talked about the entry point is where the code starts. So for us, our code would start at line 9. So this is where our program or application starts. And then what happens? Well, then the computer goes through this main line for line, going down. All right. So what do we do if we wanted to do some things in some cases and not in other cases? We've already looked a little at it in the last session where I kind of introduced statements, but let's look at it for real here. So let's introduce an if statement. I think that's even the first one on my list. It is. So an if statement is used when you want to branch your code. What does that mean? Let's imagine that we have a player and he has some health. So we could say this was the health of the player. Let's set it at 100. And then if the player is dead, so their health is 0 or below, so we say health is lower than or equal to 0. What's another way we could write this? We could also say 0 is bigger than health. I also believe we want an equal there. There we go. Right. So let's just go with that for now. So in this case, and then notice that I do the curly braces to start a block. Technically, the first statement after a selection expression will get run. So for the sake of example, let me just do console.writeLine player is dead. There we go. And let's try and build. And I'll just very quickly go to C# bin for binaries, debug, because that's what we're building, the framework, hold down shift, right click, open PowerShell, click the dot, a slash, press tab, go to the exe, press enter, and we don't get anything because we have 100 health, so our player is not dead. Well, what happens if we had 0 health? Let's try building that. Well, now our player is dead. So notice that we go from skipping this piece of code to running it. When the expression, remember we just looked at what an expression was, it's something that returns a value. Inside of the if becomes true, becomes a Boolean true. So this is the Boolean operator. I can hover over it and it says bool operator, right? Now let's look at if we wanted to have multiple lines here. So then I'm forced to do a block. Let me just do it without first so you can see it go wrong. So we will say player is dead, game over. You can even see that it is moving my code here back for me to help me visualize what's actually going on here. But we want to put it there just to be as obtuse as possible. We want to build this. We want to run it. And then player is dead, game is over. All right, that looks correct. But then what if we had like 1 health left? Well, game is still over somehow, but it's not. And that's because the statement runs the first statement after it in the case that it's true. So we don't want that. So we put blocks around it. A good tip here, though I'll cover best practices later, just always do a block for these. So let's try again. Build, run it, and we get nothing, which is expected. Right. So what do we do if, now we know how to branch into some code based on a condition, but what do we do if we want something else to happen if this condition is not true? So in the case of our player, if we aren't dead, well, then we want it to print out, player is not dead, right? So you might think, well, then we just put it here. Console, right line, player is not dead. And we build. And indeed, we print out player is not dead. But then let's try killing the player. Let's try and set this to -1. I'll build. I'll run it. Now it says player is dead, game over, player is not dead. Because, remember, we looked at it earlier, that all the program does is just run everything, all the statements, just line for line, all the way down. And there is nothing telling it not to run this. So it just runs it. Well, how do we put it so that in the case of our player not being dead, and only then we run this? Well, we could put another if around it. So we could say if, and this time I'm going to say health is bigger than 0. So as long as it's not 0 or lower, we're good. And then I'll do a block, and then I'll put this here. Now let's build. And let's look at the code. So now it only says player is dead, game over. And if we're alive, so we have 1 health. That's enough for us to be alive in this case. Player is not dead. All right. But what's another way we can do that? Well, there is something called the else keyword. So immediately after an if statement, you can do an else. And I'll just do the braces there for clarity. And what this does is, instead of when this is true, if it's false, then we run the else. All right. So let's try now. So health is 1, so this will be false, so this won't run. So then we will go down to the else, and then this should run. Let's try and see. All right, player is not dead. And if we put a minus in front of it, and we build, player is dead, game over. So that works for us. Whether or not you should have 2 if statements or an if else is up to the context of what you're working with and what is most readable. Another thing you can do, since this else here is just, a statement that runs code, much like our if here, is that we can also chain if statements to our else. So we can say else if, and then we can have some other condition here, like let's say that health is bigger than 100. Player is very player is very healthy. I can't spell. There we go. Healthy. And then if it's not bigger than 100, but at the same time we're still not dead, then we can just go else player is still alive. Just barely. We don't know. All right. Now let's see what happens when we run this code. So right now we're at -1. So we should run this block in here in the if. Let's see if that happens. Player's dead, game over. Good. Now let's try putting it at just 1 health. So now what should happen is we go in here. Health is bigger than 0. So this is false. Then we go down here. Health is not bigger than 100. So then we go down here, and then we should run this. Right? Let's see if that's what happens. Player is still alive. Good. And if we give him 101 health, that's more than 100. Last time I checked. Player is very healthy. So then we run this, and then we go down here. All right. So that's the if and the else. Then we have something called a switch. So imagine that we wanted to print out different messages depending on how much health the player had. So we could be chaining if else all the way down to write all this out. But is there a better way to do this? And the answer is yes. If I do a switch, and you can see it gives me the snippet, so I'm going to press tab, and we want to switch on. So that's the variable that we want to basically do our conditional checks on. Health. So switch on health, right? And then we need to make cases. So I'm going to press enter. There we go. And let's say we have a case where health, if I can spell, health is below, or wait, below or equal to 0. Just like before. Just make sure that I'm writing this correctly. Whoops, that's not what I want. I want to switch. There we go. Okay, I'm not. There we go. Like that. There we go. All right. So what error do we get? Yes, yes, yes. Excellent, excellent. Okay. So now it's asking me to put in a break. I'll show what a break does in a second. Let's just put it in so that we only have one error on this. Now it's telling us cannot implicitly convert type bool to int. And that's because that the switch doesn't quite operate like our if and else from before. This isn't a conditional as such that we are doing here. What we are checking for here is if whatever we are switching on matches this. All right. So does health match health less than or equal to 0? Right? That doesn't make any sense. Like I could try putting that here. So health equal to health less than or equal to 0. And we should get the same error. Or when that looks like it. Cannot implicitly convert type bool to int. The exact same, actually. Excellent. Right. Because that's essentially what we're doing here. We are checking, is this value the same as some other value? Okay. Like, I believe this would even be the correct thing to do. Operator equals equals. So, is it the same as? Cannot be applied to operands of type int and bool. Remember types? This is an expression that returns a bool, and this is just an int. So you can't compare those. Okay, now we have that figured out. So what can we do here? Well, we could say if the player's health is at 0, then we could print a message that says player's health at 0. We could make a different case. So we could make case 100. Console.writeLine player's health at 100. We need to put a break after it. Let me just do that real quick, just with a quick formatting. Again, to do that, I pressed Control A to select it all, and then Control KD. So hold down Control and then press KD, and that fixes the formatting for you. So let's see what happens if I put my health at 100. I'll build, I'll run it. Player's health at 100. What happens if it's at 0? And I remember to build. Player's health at 0. And if it's at something that we don't quite cover here, like let's say 1, and I forget to build again, there we go, then nothing happens, except, not really. You see this default case down here? That is what is run when it doesn't hit any of the other cases. So let's do here. Console.writeLine player's health is something else. There we go. Build, and then run it again. And you'll see it's because we hit the default case down here. So that's very simply what you use a switch for. Normally, what we use a switch for is iterating over bit flags, bit fields for that sake, types, to see which type something is, enums. So Or if we have, you've probably tried using a Discord bot maybe, where you can write some commands, you could switch over the commands. It's I would say it's not a good use case for right here, where we are trying to print out messages based on some health value, but it was the example I could just come up with. A different example we could do maybe is we could have some string, and then we could say that this was like a like let's say it's a point and not a point and click game. What are they called? Like text-based adventure, right? So this is the player command. So this is the command that the player types in, and let's say that the player types in move. Okay, and then we can switch on the player command. And you'll see that we get errors now because now it's a string. So let's say, what if the player typed move? Well, then the player moves. What if the player typed stay? And the player stands still. And then for the default here, it could be I don't understand that. Right. So let's try this. I build. So right now we're moving. So let's see what happens. Player moves. Good. What if we stay? And then I build. Player stands still. Good. And if I say something like pick up, build, I don't understand that because that's a command we haven't made here. So that's a more legitimate use case for it. Does the page, the switch, say anything I haven't covered? I don't believe it does. Right. Nope. Okay, so this, right, this fall through. So let's say that the player types walk. And we also want the player to move in that case. So console.writeLine player moves. And then we break. And then I'll build. Nope. I'll set that to walk and then I'll build. And we see player moves. All right. So we basically want it to run the same code in two different cases. Well, what you can do is something called fall through. So in the case that we get walk, if I delete all this, so it says case walk, and then right after that, another case, well, then if the case is walk, then it will do what's called falling through into the other one. So let's try building this and see if we get player moves. We do. So if we now type walk, we fall through our walk case into our move case. Okay. And I don't believe anything else. No. There's something about if it's an object, but we'll get pattern matching. Yeah, we'll get to pattern matching later. This looks fine. Right, you can see another example here where they use it for coffee. where you can either write 1 for a small, or you can write small, and then you fall through. And that's the type thing I was talking about. We'll get back to that. All right. I think that about covers switch statements for now. We'll get back to them once we start looking at custom types. So for now, that's switch and case. Now look at iteration. So iteration, I even looked it up in the dictionary real quick here. And if we look at 2b, we have the repetition of a sequence of computer instructions a specified number of times or until a condition is met, which could not fit better at what iteration means in our case for us. So let's look at what we have. I'm going to start at 4 instead of do right here. So the 4, if I use the snippet real quick, you'll see that it writes out something for us here. It writes out, it writes out int I equals 0, and then end of statement, right? Semicolon. Then it has some comparison expression here, end of statement. And then it increments I, so it adds 1 to I. And then we get a block. So what does all of this mean? Well, the first part here, the first part of the 4, you can initiate or declare any number of variables that you will need in your 4. So we could do an int I. We could do an int j. We could do a, float z, whatever, really. The error I'm getting here, though, is that it wants me to initialize them. Right. I didn't show that. I should probably show that. So real quick, let's go back to types, type declaration. If I have an int I and I have an int j, I can declare those on the same line using a comma, like that. And I can still say that they are initialized to something. All right, now you know. Great. Let's go back here. So I would have liked to be able to actually, is it not, can I not just, uno momento. See, I never really do more than 2. Yeah, I should be able to just do anything I want there. Why am I not? What is the error? Okay, identifier expected. Where did I type something wrong? That's correct. That's correct. That's correct. That is weird. Whoops, I lost my equals to 1. Oh, this is embarrassing. Is it just because I'm not allowed to... Nope, this should still work, right? Like, you can do int I, j, float, set, equals to 0f. No? Why is this not running? Is it because I'm... So it must be because I'm declaring variables here. So if I wasn't declaring variables, I should be allowed to just put in whatever. Right. Excellent. So it's because I'm declaring variables. With that little minor hiccup out of the way, you can run any code in this section, is what I wanted to get to. It doesn't even, I don't even think you have to do any sort of, no, you don't. You can just run any code you want, as long as it's a single statement. I think that's where I was going wrong. It had to be a single statement. Right. That makes sense. Yes. This is one statement, end statement. This is one statement, and that's one statement. And they are all optional. That's another thing. You don't have to fill in any of them. Just like that. But let's go back here. So let's have int I. Let's set it equal to 0. Let's put our condition to be when I is smaller than 10. So as long as I is less than 10, then we will do what's in our for loop, and then we will take I and increment it. So make it one bigger. And in here, let's just print out I. Let's build. And let's run it. And we get 0, 1, 2, 3, 4, blah, 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 all the way up to 9. Because it makes sense that once it is 10, it is the same as instead of less than. And we exit. So sorry for the confusion, but that's simply what a for does. It's 3 statements. Whenever the middle one returns true. No, sorry. Whenever the middle one returns false, we exit. There we go. So if I just did this, for instance, build, run it, you'll see that we get nothing at all, not even the first right line. All right. And if I put true here, you could imagine that it kept running forever. And if we put nothing, it would also run forever, which I'm not going to show because I don't feel like crashing right now. No, you know what? Fuck it. Let's do it. Let's show some crashing. Gives me an excuse to drink some coffee. Okay. So it's counting away, and then at some point we're going to run out of memory. I actually think I have a lot of memory on this one. So I think it's going to be a while. Oh, no, wait. Yeah, it's not even close. I have too much memory. It's gonna take way too long to crash. I'm sorry, guys. Maybe if I didn't write anything out. If I build this and run it, will we crash then? Will I be fast enough? Oh shoot. Yeah, that's gonna run. Oh my gosh, just run out of memory already. Why do I have such a big computer? Okay, never mind. So to kill the current process that's running, I'm gonna hold down Control and then press C. That kills it. Just because I'm very impatient and I can't kill my computer. Um, Trust me, you'll run into memory problems here. Now let's look at some of the other ones. So that was 4. We'll do for each later. Let's look at while. So while is where most people run into memory issues because they never put in a condition that then gets you out of the while. So while, much like the for, keeps iterating, so running over and over, um, as long as the expression inside of here is true, much like for the for loop. So you could imagine why most people run into issues here is because they forget to create a condition that's then false when they're done, um, or jump out of the block. With the for loop, at least, if you construct it in a usual way. So, let's go back to the for loop real quick. And then let's say that, um, for each player, so let's say there's 10 players, we want to print, so we want to console.writeLine player, and then their number, and then it's ready. So here I'm concatenating an int to a string. I can do that because, much like with just writeLine, string can figure out how to turn an int into a string. So let's go through this list real quick. Player blah 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 is ready. Okay. Now let's imagine that we wanted it to be 1 base. So instead of player 0, it would be player 1. So here I can just put a little parentheses around it, say +1. So now it will be whatever our I is for that iteration, +1, concatenated to our string. Let's build that real quick. And we can see that it works out just fine. Now, how would I do this with a while loop? Right, so much the same idea. Let me just copy this out real quick. Put it here. Let's do our while. So while I is less than 10, that's our condition from before, except now we have to make I outside of the loop. So we will say int I equals 0. And then after it has run, we then need to increment I. So down here, ++1. And then let's grab this, put it back. So this is functionally the same we did in our for loop. While I is less than 10, print this out, increment I by 1, check the condition again, repeat. So let's build it, run it, and we get the same. So that's pretty good. What's a different way we could do this? Well, we could say that my condition condition. There we go. And then I could make a my condition. Let's keep I. Let's make a bool. My condition. Let's actually turn it into something. Let's say is all players announced? Or is all players ready? Right. So when I name my booleans, I normally put has or is in front of it, even if it's grammatically wrong, just so that I can always read it as a question, because this one might be a bad example, but let's say the bool is just elephant. Then you don't know what true or false means, but if it says is elephant, then we know it's asking a question, is it an elephant? And if it says has elephant, then it's asking, does it have an elephant? So phrasing it as an is or a has question, I find very helpful for reading these variables. And we will start this at false. Is all players ready? False. They start out not being ready. And then we will say while, and then I'm going to introduce you to a new symbol here, or operator, exclamation mark, which is the not operator. If I hover over it, I don't get anything. Do I get anything now? There I do. Bool operator not value. So what this does is just reverse whatever the value after it is. All right. So if it's true, then it becomes false. Let me show it real quick. So console, the right line, is all players ready? Not. So that should print out true. Anyway, back down here, is all players ready? Then we write out the player, and then we increment, much like before. But then we need to do a check. So we could say if, and then some condition like I bigger than 10 or equals to, for that matter. Then is all players ready equals true. Actually, we could just say equals equals because we know it's going to hit 10. I could run this and it would work. Let's just do that. There we go. Also, notice that it printed out true here. So it just reverses the Boolean value. Right. And we count through to 10, and then we hit here. At some point, it becomes 10. This is set to true. Since it's set to true, this becomes false, and we jump out. Is there an easier way to do this? Well, remember how this evaluates to a Boolean? So I could just take that and then assign it, right? Like that. Much easier, much more readable as well. Well, let's try and see if that works. It does. Right. Because remember, the thing inside our if is just an expression that evaluates to a Boolean. So a lot of the time, if you have some Boolean that you are using to check your condition, what you really want is not an if that then sets it to true. What you really want is the result that you are testing, right, your condition, to then be what that variable is. Okay, cool. That was very simply our while. Now what is do? Imagine that we have something that we want to iterate on, but it has to run at least one time. So imagine a case where we have a Boolean, and I'm just going to say my condition. And I'm going to set it to false. And then I'm going to make a while, and I'm going to put in my condition. And then we're going to console.writeLine, what up? Will this run? I mean, it will run, but will line 12 get executed is what I'm trying to ask. All right, let's look. So I'm building. I'm running it. Nothing. Right. Because it's false, we do our conditional check, we immediately jump it. But what if we at least wanted to run this once? What do we do then? Well, then we do a do while. So I'm just going to do the snippet for that. Get rid of that. Control KE, just to make sure it's all pretty. And then we put in my condition here. So now we should get at least one console.writeLine what up, because the do gets run first, then we check our condition. If it's true, we do our do again, etc. So let's try that. Whoops, I forgot to build. There we go. To really illustrate the difference, I'm going to do an int I equals 0 while I less than 10. Console.writeLine I, and then I'm going to say I 0 do while I 10. Plus I. And let's just do a little line here. Whoops. Just to separate it. Whoops. There we go. So what should we expect from this? Well, actually, just make sure it doesn't run for infinity. There we go. All right, so what should we expect from this? All right, let's build C. Well, they both run up to 9. And why is that? It's because that fundamentally our do here, the only thing that it does is that it guarantees us that our while runs at least once. It doesn't really mess with anything else, such as, the number of times it runs beyond one. Whereas our while here runs 0 or more times, our do while runs 1 or more times. That is the only difference. Again, let me try and show it here. So if I just turn these around, so now I has to be bigger than 10, which it isn't in both cases. Now let's see what happens. Right. We get the line, and then we get 0, because we are guaranteed that our do while will run 1 or more times. So that's the big difference between it, really. And very rarely will you need a do while. So if you run into it often, please tell me. You have some interesting projects in that case. So that is our do. Now we have our jump statements. And I can already see that we are getting close to an hour, so I'm probably going to end it after we go through some of these. The first one is break. Pretty good one to cover. So we already saw break in our case with the switch. If I just do a switch real quick here and then press enter. Didn't do it for us, but I'll just do a break myself here. If I hover over it, I don't even think I get in. No, I don't. What does that do? Well, break takes it out of the current block we're in. So what does that mean for us? Well, let's say we have an if, and I'm just gonna set this to true for some reason. Oops. And down here, I'm just going to say console.writeLine after if, and then we will have console.writeLine start if, and then console.writeLine and if. And then we will put a break here, and then we will see what happens. Ah, right. It has to be in a loop. So let's just do while true. Much better. It's even telling us right now, I think, that we'll never reach this. Yeah, unreachable code. Okay, so start while, end while, after while. Let's just run this. I'll build it. And we will get start while and after while. So break takes us out of the current loop we're in. All right, simple. Let's try and nest some loops. So let's put a while inside of here. And then let's put a break here, and then let's remove this break. Like that. Built it. And let's see what it does. Do you see the issue? Right. So it takes us out of one loop. Okay? It doesn't take us out of all of the loops. I would need another break here to take me all the way out, or after it. Like I could put the break after it here. And that takes me all the way out. So let's try that again. We start while 1, start while 2, we end while 1, and then we are after the while. So we skip this line. That is what break does. We can also do it in a for, just any loop, really. Let's say 10, and then let's say if I equals to 5, break. And then up here, let's say console dot write line, and then let's print out I, and let's build that and run it. And you'll notice that after 6 iterations, because we start at 0, we will break, and that will not take us out of the block, which was super wrong of me to say. It will take us out of the loop. Okay, great. Let's break, continue. Okay, So continue takes you on to the next iteration of the loop. So let's show that real quick here. Let's just say hello plus whatever the number is here. And then when we get to 5, I want to continue instead. Now let's see what happens. I didn't build. So we go 0, hello 0, right? And then boop, 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 boop. And then we say 5. So we print out 5. If it's 5, continue. So that means skip the rest of the lines in this loop and go to the next iteration of the loop. All right? See how we skip the rest of it? Cool. Now, that also works in a while, of course. Let me just do like an int I, set it to 0. We can say if I equals 5, continue, and then let's print it out. And then let's say when, I is equal to 10, then we want to break. There we go. Build, run it. Whoops, I forgot to increment. What? Wait, what? Did I forget to build? Oh, right. That's funny. So notice how, remember I said continue skips the rest of it? Well, I put my increment at the bottom. So as soon as we hit 5, we skip the rest of it. So I've accidentally created a loop. Let's fix that by putting it at the beginning. And build. And run it. There we go. Whoops. So we go 0, 1, 2, 3, 4. And well, you can't really see me skipping it now, can you? Let's put the right line after. There we go. So we get 1, 2, 3, 4. We skip 5 because we continue here all the way down to 10, and then we break. Great. That takes care of that. Default we already covered. In the case, it's when we don't have any cases that match, we fall down to default. Go to, we're not quite gonna do yet, and same with yield. And return might not make a lot of sense to you just yet because you don't know what a method is, but let's try. So notice how we are inside of a class, and inside of that class we have a method. This is a method. It's a method called main, and it returns void. Inside of a method, as soon as you hit return, you exit the entire method. All right? So let's try that. Let's say that if I equals 9, then we want to return. So this takes us out of the entire method, not just the loop we're in, the entire method. All right, let's build that and let's see what happens. So we count 1, 2, 3, 4. We skip 5 because of the continue. We hit 9, right? And then before we get a chance to write it out, we have returned. So we are out of the entire thing, and you'll notice we don't even print the stuff after the loop because we are completely out of the method by now. If our method returns something like an int, you'll notice that we get an error here because we need an object that can be an int, such as 1. Now we're good, except that it's saying something here. It's saying not all code paths return a value. Now we know, because of how this is written, that we will hit here. But in case we have branching, which is what a while is, for instance, if I did an if true here and then I wrote something, then we would maybe never hit down here, or whatever, or a while true up here, so it's saying, I might never reach a point where I hit a return, is what it's saying, because we have branching. So we also need to put some branching, or put a return at the other branch. What would the other branch be? Well, that would be after our while, would be the other branch. So let's put it here. And now we're good. It's maybe a little clearer if I show it with an if. So if I say if false, return 1, and then it's saying not all code paths return a value like before because we are branching here, even though it is arguably going to never run. If I say true here, well, that's because it can see it's true. That's cheating. Let's imagine it couldn't see it's true. So the compiler would have to figure this out at runtime, right? So not when we're building. Then it's going to go, okay, I need you to return at the other branch. So that would be down here. Return 0. And now it's happy, except it's saying this will never get run. But let's just act like that doesn't happen. Anyway, if I had an else here, and then I had return 0, it would likewise be happy, because now we do return at each branch, because we are either going to run this or this no matter what for what we are doing here. In some cases you might not, in which case the compiler will actually yell at you, which is nice. So this down here would then never get run, because we would hit the else at least. All right. Let's go back to what we had before. I'm going to Control Z a whole lot, and then let's look at it again. Okay. So just going over it one more time. While true, so we keep iterating forever. We increment because we hit continue at some point, so we need to increment before we start skipping. We write out down here, so we go 0, increment, so that's 1. We write it out, 1 in the console, 2, 3, 4. We hit 5. We skip the rest, so that doesn't get written out. We come up here, we go 6. That's not the same as 5. We go down, 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 write it out. Keep going until we hit 8. So then the last one we wrote out was 8. We go down, go up. So now it's 8 plus plus 9. It's not 5. It is 9 though. So return takes us out of the entire method. And that means this never gets printed. Very basic introduction to control flow. We will look a lot more at control flow in the future, so don't worry. And there's some other stuff here we will also look at in the future. All right. So I highly suggest you play around with what we have had here today. Try doing certain control flow operations on the inbuilt types that we've looked at. Experiment. It's a good way to learn. Look at the documentation, and good luck coding.